Thank you, and I'm going to rely on my notes, so I'm going to stand over near the table. But thank you very much for having me today. It's obviously a topic close to my heart. If I can explain what the life sciences industry is, it's really it's companies like Cochlear and CSL that are the most developed and probably the ones you know. But there's a whole cohort, hundreds of small companies in our ecosystem developing life-saving technologies at the very early stage. So they're bringing it out of the medical research institutes and out of universities into a commercialisation process that might end up being sold by a major pharmaceutical company or a major medtech company. So just to give you a mental model of what we're talking about, that's the place in which I work is around that development of companies and enabling them to bring their technologies to market. So biotechnology is another term for life sciences, and probably because I work for AusBiotech, we talk about it as biotech a lot more. More recently, life sciences is a more common term, and it's really the application of technology with biology. So technology that interacts with or is based on cells and living organisms. So we therefore cover plants, animals, human beings, and microorganisms. I think the life sciences industry develops therapeutics and pharmaceuticals. So the cervical cancer vaccine would be one of the big ticket items to come out of Australia. Medical technology, which includes diagnostics and devices. So the cochlear implant or the pathology test that is used when you go for a screening test, like a prostate cancer screening, for example. And then there's a range of other things that cut across our sector, like artificial intelligence is being used more and more in clinical trials and in monitoring and diagnostic devices. And one of the convergence is something like a tattoo that's got capability to transmit information about your health to your GP. So we're seeing a convergence of all the different technologies in our area from their discrete areas into things that cut across a whole range of different careers, most importantly. We work in the agricultural and food technology space as well, and there's quite a bit of technology going on in that space. So one of the examples of an agri-tech product is the virtual fencing technology that's being used with cattle at the moment to move them around pastures. It's quite incredible technology. So in essence, the industry looks for solutions to diseases, to climate change, to fuel alternatives, to food security, and a whole range of things in between. So it's a very broad sector to think about in career terms. We seek to treat diseases such as cancer, hepatitis, HIV, and ways to feed a growing population, which is expected to exceed 9 billion people by 2050. To think about how we can get more out of our crops, particularly when we have problems with only being able to use our agricultural space down the east and around the seaboards of Australia, not in the central areas of Australia. And the salinity problems that we have in doing that means that we have to be much smarter about how we run our agri-tech. The industry in this area is a game changer in a range of technologies, but it also underpins our economy in Australia. So as we grow, we're starting to see significant return on the stock markets, in clinical trials, in jobs, in medical research, right across the spectrum. So we're seeing a vastly growing area of value for the community, in addition to the solutions that are being developed. If I can tell you a bit about AusBiotech, forgot to slip to that one before. AusBiotech is Australia's industry body. We've been representing the sector for more than 34 years, and we were started by a group of CSIRO scientists who wanted to get together and talk about their technology. And about 15 to 20 years ago, we realised that there was actually a burgeoning sector in Australia and that sector needed support. So AusBiotech has moved its purview into just looking after industry. We have universities and medical research institutes and a whole range of different players in our membership, but our core constituency is young companies developing technology. So we've got 3,000 members at the moment, and they span all of the technology areas that I talked about earlier. So what do we do? I think it falls into these main categories. Australia is a leader in this area, and I'm not sure that many Australians realise that, but we sit in the top 5 in the world when it's adjusted for population. So we're bet above our average, and on the world stage, I've just come back from the biggest biotech conference in the world, and we're amongst the top 10 delegations always, and people are really keen to partner with us. Our science is world class, and our capability in commercialisation is actually very good. So we work with our members to find out what they need. We're focused on reducing barriers to market for those products and leveraging the amplifiers for them. We work with government a lot to make this happen. We work on consultations, regular meetings about economic drivers, and we have 19 committees within the membership that look at specific areas of interest because the area is so broad. We need all of those different geographical and technology-based groups to give us advice about what they need and what needs to change in the environment. AusBiotech is very interested in networking, and networking can sound a bit nebulous sometimes, but this organisation started with those CSIRO scientists holding a conference to do exactly what you're doing and to learn from one another and to learn from people that are developing in the sector. And that's turned into, we run 70 events a year that range from small round tables to the biggest industry conference for the sector. We also run luncheons for women to talk about progressing women in STEM and those sorts of areas where women who are advanced in their career can sponsor a student to come along to an event and meet some of those people and get an idea of what sort of career trajectories they could be working towards. Access to capital is also a really important area for our sector. It takes between 10 to 15 years to develop a product from the medical research that shows promise as a proof of concept through to a product that is approved by the TGA or more commonly the FDA in the US. And it takes millions of dollars, sometimes tens of millions, sometimes hundreds of millions, sometimes more than 2 billion for one product. So I've got a member at the moment that's just spent $40 million on an ophthalmological product and they're in phase 2, which means they're still a long way from the market, and they've got no revenue. So they're looking to attract this money for people to give them enormous amounts of money to be able to test something that may actually fail. So it's a really risky development process, and it goes for a really long time. So those economic drivers are absolutely critical. If you think about whether or not government has a role in that, government usually steps back from that as it leaves the medical research institute or leaves the university. It's really up to industry to commercialise that product. So think about whether the government's ever funded something to come to market. They haven't. So probably the nearest thing you could argue is that CSL started as a government organisation and worked in blood fractionation, and that you might argue that government helped a long way into the commercialisation process on that, but that's really the only example. I think, so AusBiotech works to connect companies with investors, and we take groups of life sciences companies around the world to pitch to investors. And as a result of that, we have a lot of investors in our membership, and we work very closely with them around, many of them become involved as directors of companies, and so all of those people benefit from having a life sciences qualification and life sciences background. So if I can tell you a bit about the sector, that slide that you're looking at is really how we think about the different parts that make up the sector. Industry is only a small part of it. It takes a lot of people to work together to make the technologies, to develop the technologies along the pathway. It's that full pipeline from bench to business to bedside. I think most importantly, we consider research institutes and others as very much part of that development process. It's a growing and maturing sector. It's active and substantial in Australia, and it's, as I said earlier, we're known for our biotechnology expertise, but we're also known as being a really innovation progressive country, despite some of the policy rhetoric that you may have heard around the last government's innovation agenda. Innovation is very much alive and well, depending on what you call it. We've got more than 1,650 organisations in Australia working across this sector, and 230,000 staff, employees, and that makes us broadly comparable to Australia's largest industries in people terms. I think if we focus in on the industry component of that, of those 1,654 organisations, 53% of them are industry-based, or what we call companies, and that's where we'd see CSL and Cochlear sitting in that group. The industry in Australia used to be dominated by human therapeutics, but the mix has evolved substantially in recent years. It now includes the digital health sector, a steadily emerging regenerative medicine sector, and you may have heard some of the hype about immuno-oncology and some of the cures that are tantamount to miracles at the moment, where we're seeing people with very, very advanced stage cancers being cured completely with one application of a product. So a CAR T therapy can actually take somebody from near death to cure. And those therapies are costing enormous amounts of money, but they're both to develop and to buy. 5 minutes. I'll be going with it tonight. So I might just skip over that. So each year we survey our members and have a look at what they're doing in terms of clinical trials, what they're putting into patent protection, and what they're doing in terms of jobs, that sort of thing, and understanding what levers are concerning them at a policy level. And you can see the jobs growth or the job sentiment in Australia was just after the GFC at the very beginning of this chart. No one was hiring, and there was no intention to hire. Everyone was looking to pare back. And we've seen a complete reversal of that with the introduction of the R&D tax incentive in Australia. So that was a policy lever that made an enormous difference in a really short period of time. I wanted to talk just a bit about women in biotech. Biotech faces the same gender equality challenges as the broader STEM industry, and attracting, I'm sure you're all familiar with the concerns about attracting women into STEM, and that's not happening at a fast enough rate. And our industry is probably the one most concerned about that. But once people get into industry, we're seeing that as they become more senior, the gender balance is changing over that period of time as well. And we're trying to understand that much better and help women to progress into director roles and CEO roles and the like. So I just wanted to talk briefly about the sort of careers that you might hear about or might think about when you're thinking about biotech. And I'll just read through a bit of a list that I compiled in 5 minutes yesterday. So we need marketing professionals, we need management professionals, business investing expertise, business development expertise, engineering. Most medical devices need an engineer to put them together. We do cellular engineering is really important too. Microbiologists, geneticists, process development scientists, bioanalytical chemists, biodiscovery research scientists, biotechnologists, plant breeders, clinical researchers, medical sales representatives, patent attorneys, pharmaceutical representatives, policy officers and managers, production technicians, quality assurance managers in manufacturing, research and development scientists, and just to name a few. Really, I could have sat and written another 3 pages. Yeah.
What level of experience for those roles do you require?
Well, I think it's fair to say that all of those require postgraduate qualifications, and the roads to many of those are discrete and varied in their discretion. So it's not a question I can probably answer easily. All of them will have a science underpinning. So an undergraduate.
More for somebody in their 40s, or are you looking more for graduates in those roles? I suppose that's
well, a graduate in this, so I sit on the advisory board for Melbourne University's Master of Biotech, and the people in those courses would not be ready for industry just yet. So even at master's or PhD level, so we've got a program where we mentor PhD students in STEM to do industry mentoring placements, and even then they would be considered entry level. So it's fairly, usually you'd see, a patent attorney, for example, has a science degree and a specialisation, it's not law, a specialisation in patenting. So you usually see people with 2 or 3 postgraduate qualifications on a science basis.
as well as experience.
Sorry?
Are you looking for experience as well?
I don't think that it's so much about experience, to be honest. I think though the education process is so long in this sector that you've usually had quite substantial interaction with industry by the time you graduate. And, we see, we have a volunteering program at our conference for PhD students to come in and volunteer. And most of those people will, as a result of that, go in to do a work placement and get a job. So experience is probably, the industry is desperate for trained people. So we're bringing them in from internationally because we can't train them fast enough. So, but there's lots of opportunities and lots of options.
Lorraine?
Yeah,
am
I done?
Yeah, no, go a bit. I've just got a question in terms of, from my research, the industry being one of the biggest employers now, or creating new jobs, because these inventions, these researchers are then becoming startups, small businesses. So is there then opportunity for sales, marketing, all those sort of business management opportunities because they're becoming small businesses?
Yeah, definitely. So the juncture between science and business is critical. And what we often see is we'll have a scientific founder of an organisation that can't take the company through the process completely, and at some point they have to partner or bring in a new CEO that's a business specialist. But we often see those skills. So more recently we've been recommending to our master's students that they get an MBA as well, and that's a more common presentation is a science qual and an MBA. But essentially we have so few people that have in Australia that have actually been through the entire process and taken a company through to commercialisation that the experience skills are still important, but we need to be working on all those different levers throughout. So we need people upskilling in our universities and TAFE institutes, but we also need from the very early stage, people coming through STEM subjects is really important for the funnel of what eventually ends up in the workforce. And we've been doing a bit of work around trying to understand what the skills gaps are. And so one of the biggest ones at the moment is bioinformatics. As we're applying data to technology, how do we organise that data? And it's really even as simple as I was just listening to a woman speak who's works for the WHO, or she's actually on one of their advisory committees, she doesn't actually work for them. But they're looking at producing a registry of people that have their genes edited. Because at a global level, we don't know what the effect of that is going to be in 20 years' time. We know that we can cure something now, but we don't know whether that disease will reoccur right down the track or what the implications are. So that wanting to capture at a global level what's going on so that we can go back if we need to go back to those people and say, we've recognised a concern, is not something we've ever done as a global community before, and they're really how we organise that information into a database, because everybody has to capture the same things in the same way, otherwise it doesn't work. It's quite simple stuff, but it's really complex to do. So bioinformatics training and IT application to artificial intelligence to biotech is going to be critical in the future too.
Does anyone have any other questions for Lorraine? Okay.
Thank you very much for having me. Enjoy your day.